Welcome back to the 10th part of the elementary statistics series. We're going to be looking a little bit more details about the standard deviation here. And one of the things that I want to point out, and we're going to do a simple exercise in T-SQL as well in a second. One of the things I want to point out is that the standard deviation is going to be 0 if all of the values are the same. Because if all of the values are the same, then that means that the average is the same, right? So that means every point subtracted from, like every observation subtracted from the average, the mean, is going to be 0, right? And 0 squared, 0, any number divided by, 0 divided by any number is going to be 0. That's also important to note because as the spread of data, right, as the data begins to spread out, as it begins to grow, the standard deviation is going to get larger, right? So if we do, let's say, a sample of 10 people, and all 10 people can do 5 pull-ups, right? The standard deviation is 0, right? Because the average is 5. 5 is what everyone can do. Standard deviation is 0, so is variance is 0, right? Okay, but what happens if we take a population and most people can do 0, but a few people, let's say, one person can do 10, one person can do 30, and one person can do, let's say, 100, even though that's not possible in a minute. But for now, I think the record is 51. Okay? Because we have some data points, we're going to expect that to start to spread, right? So that's something to keep in mind. And we're about to look at a demo of this. The standard deviation is heavily influenced by outliers. Okay? So one outlier can really throw things off. Now, if you recall, let's go back to our data here. When we have these values here, we have our 20 values. And when we calculated the average and the standard deviation before, and in fact, it'd be better to just go ahead and do them together now that I think about it. So let's just go ahead and remove this, and let's stack them up side by side. What we're going to do is we're going to remove the outlier value. It's a standard measurement of an outlier, I should say. It's on the second one, where the balance is less than 240,000. We'll cover that in a later video as to why I'm defining it that way. But we'll see that if we include all of the values, the average balance is 26,750, and the standard deviation is close to 69,000. Not exactly, but it's close to 69,000. So look at what happens with that one outlier included. So yeah, it's very much impacted by that. But when we remove that outlier, the average drops to 12,368, and the standard deviation drops to 25,600, right, or 25,600-ish. So the standard deviation is definitely impacted by outliers. So it's something to keep in the back of your mind when you look at data points. We do use a standard deviation. I'm using the standard deviation here to filter out. I'm using a average plus 3 multiples of the standard deviation, and that's about 240,000-ish. So anything above that I'm wiping out. But then that's going to re-impact the data. And in fact, there were a couple of examples I can think of, problems that I had solved, where once we did that as a case in point like this, then we would go back and we would do yet a further example. So as a case in point, let's use this one as an example. This is a good demo here. Because we used 3 multiples of the standard deviation, we added that to the average. Well, look at how the values change. So now we're looking at 12,000-ish. Let's round up to 13,000. So we're looking at 13,000 plus 3 multiples of basically, let's say 25,000. So 25,000 times 3 is 75,000. 75,000 plus 13,000 is, what is that, 88,000? So that's going to knock off the other outlier, which was, if we had, what was it, that would be 100,000. Now that actually is not an outlier on the overall data set, but we might want to compare the results and see what we get when we do this. So there's 2 values now that are gone, and our average drops. Still, if someone were to ask me, do I just keep doing this and doing this? No, you would definitely want to compare, but if there's any value that's pushing that limit, and probably in this case I wouldn't do the 100,000 because it's you have 300,000, you have 100,000, but let's suppose we had a value that was, let's just say 225,000. Look at how close that is to this, and what of an impact that would be if we removed it. So it's something to keep in the back of your mind. I mean, as you practice more with statistics, as you practice more with these values, you'll become familiar with when you want to do that and when you don't want to do that. But it is something to just keep in the back of your mind that standard deviation, the calculation, is heavily impacted by outliers.